We'll be switching back to the samples project for the remainder of the exercises. So, click on the Project Folder Recent option and select the Samples project.
Click on the Quick Map tab to the right of the Borehole Data tab to display a quick view of your borehole data. The currently selected borehole is highlighted with a red square. The Quick Map is a good way to find bad coordinate values. Click on the Borehole Data tab to return to the location table and other database tables. For a more complete map that can be exported and printed, choose the Borehole Operations Map Borehole Map option. Turn on the surface contours, labeled axes, and peripherals. Within the Symbol Options tab, turn on the symbols, log traces, and borehole IDs. Press the big green Continue button at the base of the Borehole Location Map menu. After a few seconds, a map will appear within a new untitled tab sheet within the Borehole Location Map dialog. There are two ways to change this map. The first and recommended option is to click the Options tab, change the map options, and regenerate the map. The second option is to modify the map within this output dialog that we call RockPlot 2D. Let's start with the first option of clicking the Options tab, changing the menu settings, and regenerating the map. Let's assume that we don't want the contours, so uncheck the Surface Contours option. We should also uncheck the Peripherals option, since the color legend will no longer make sense. Next, click on the Symbol options. Enable the raster symbols and disable the vector symbols. Click on the Raster Symbol Preview button and double-click on a symbol from the raster symbol table that pops up. The selected raster symbol will now be displayed within the Borehole Location Map menu. Now, if we click on the Continue button, a new tab is generated with a new map. The other method for modifying a diagram without regenerating it involves the RockPlot 2D tools. Layers can be turned off by clicking on their checkboxes within the layers listing. For example, we'll turn off the color contour filling and the contour lines. On the other hand, converting all of the symbols from vectors to rasters would require deleting each vector symbol and adding a replacement raster symbol. This considerable task would need to be repeated if the data changes. Consequently, we strongly recommend that diagrams be modified by changing the menu options and regenerating the diagram. Another compelling reason for this approach involves automating the data processing and diagram generation with the RockWorks playlist, a topic that we'll be covering later on. Once you've generated a map that you like, possibly involving more change option regenerate diagram iterations, select the File Save option and enter the sitemap.rw2d for the file name. Note how the tab now shows the file name. Close the entire window by clicking on the X button in the top right corner of the window.
In this step, you will create a strip log of a single boring. This is useful if you want to view many types of data such as lithology, geochemistry, water levels, etc. at the same time. Start by clicking on DH01 within the borehole list to make sure that subsequent operations use this borehole. Select the Borehole Operations Strip Logs 2D Strip Log program from the Operations ribbon. The 2D Strip Log options window will list some menu options in the panel to the left. The Borehole ID option is a way to override the currently active borehole that was previously set. The vertical exaggeration options provide a way to vertically stretch or compress the log. The projection option provides tools for unwinding curved boreholes, plotting deviated boreholes as vertical boreholes, and converting non-vertical boreholes using true vertical depth. The vertically clip log option will extract a segment of the borehole based on an upper and a lower cutoff elevation. The peripherals and border options are used to add annotations such as a corporate logo along the margins of the log. The output options provide ways to display, save, and/or export your completed strip log. Across the top are tabs to set up your 2D log. Click on the 2D Log Design tab. The 2D Log Design tab is where you establish which data items will be displayed in the 2D log. You can also adjust column placement and appearance settings for each column. To activate an item, click on the checkbox to add a checkmark. It will be displayed in the upper preview pane as a column. To reposition the item, click on it in the preview pane and drag it to the right or left. To view and/or adjust an item's settings, click on its name in the column on the left and modify the settings as necessary in the Options pane in the bottom right. Use your mouse to adjust column locations by selecting different columns and clicking and dragging them around the Layout Preview pane. Note that the log title will always be centered over the red vertical line representing the log axis. In the 2D Log Design window, insert check marks for the following items: the title, depths, lithology, stratigraphy, well construction, fractures, aquifers, bitmaps, iData number 1 and iData number 1 text, and pData number 1. All of the other items should be unchecked. View the options for the pData number 1 column by selecting the blue rectangle below the pData number 1 checkbox, or by clicking on the curve column in the preview pane, which is not shown. The track item gives you the option to choose which column in the pData table will be used to create the curve. The down arrow is used to choose the track name. Clicking on the red and blue icon to the right in the track row opens the Types table if you want to add another pData track on the fly. Select the Gamma track and click on the Fill Options tab to change color and line styles by clicking on the color and line boxes. Similar options are available for plotting bar graphs using data from the iData and tData tables. Click on the lithology item in the Visible Items list to view the lithology options on the lower right. Here, you can view or change the column width, title name, and font style. Click Continue at the bottom of the 2D strip log window. A log that looks similar to the one to the left is displayed in the new RockPlot 2D tab. You are encouraged to experiment with different settings in the 2D Log Design tab and click on the Continue button to recreate the log with the changes applied. Close the 2D strip log window. You do not need to save the RW2D file at this time.
Select the Borehole Operations Strip Logs 2D Strip Log section option. In the menu options to the left, review the categories by clicking on the tab names and viewing the options on the right. You can add details around your strip log section by clicking the boxes. Click on the 2D Log Design tab to display strip log options. Make sure that only the following items are enabled in the Visible Items listing: the title, lithology, stratigraphy, and pData number 1. Uncheck everything else. Next, click on the Section Location tab at the top, next to the 2D Log Design tab. Use your mouse to pick a borehole-to-borehole cross-section that trends north-south across the project area. Notice that the XY coordinates of each vertex along the line are listed to the right. Check the Location option on the tab to the right of the Section Location tab, and then click on the Location Map option to review the options that you want within the map. Most of the Location Map options are self-explanatory, but there are two that merit special mention. The first is the Map Overlays option. We recommend that you enable it and activate the borehole locations option. The second is the Output options. Select the option to display the map as a separate diagram. Click the Continue button at the base of the 2D Strip Log section program menu. After a few seconds, two new tabs will appear within the 2D Strip Log section dialog box. The first tab page contains the cross-section. The second tab page contains the cross-section location map. Click on the tab that contains the cross-section. As you move the cursor over the section, notice the X and Y coordinates at the base of the screen. X is the distance along the section relative to the first borehole, and Y is the elevation. Let's make some changes to this section by clicking on the Options tab. Start by unchecking the Location Map option. Select the 2D Log Design tab, check the Stratigraphy text box, click and drag the P-data curve so that it's positioned to the right of the stratigraphy text within the preview area. Click on the Stratigraphy text option, select the Interval Labeling option from the Stratigraphy text options submenu, and make sure that the Keywords option is enabled. Finally, click the Continue button. A new tab will appear with the new cross-section. Select the Zoom In tool. Move the cursor to the upper left corner of an area to be enlarged. Now, hold the mouse button down and drag the enlargement rectangle to the opposite corner of the area to be enlarged. When you release the mouse button, the screen will be filled with an enlargement of the selected region. Notice that the formation names are now plotted next to each interval.
In this step, you will create a second kind of cross-section called a profile. Instead of creating a cross-section polyline from hole to hole, you will be choosing a single line that defines a vertical plane. The program will project selected logs into that plane and plot them as a diagram. Start by choosing the Strip Logs 2D Strip Log Profile program. Notice that the program has remembered many of the choices that you made in the previous step. Add a check mark to re-enable the location map. Click on the Profile Location tab, where you will define the wells within your profile. Uncheck the Snap box so that the profile line will not be snapped to the borehole locations. Click on the starting point for the profile just to the southeast of borehole DH27. Click on the endpoint just to the northeast of DH39. The yellow swath that encloses the profile defines which portions of adjacent boreholes will be included within the profile. The width of the swath is determined by the setting at the top of the menu. Click on the Continue button. As with the previous exercise, two tabs will be created, one for the profile and one for the profile location map. Let's return to the Options tab and modify the output to be less busy. We'll start by clicking on the Location Map tab and turning off the background image. Next, we'll revisit the 2D Log Design tab and disable the Stratigraphy and Stratigraphy text options. Set the P-data number 1 column width to 2 and turn off the subdivisions. Set the P-data number 1 fill color to horizontal gradational, ranging from purple to red. Set the lithology column width to 1 and click the Continue button. The profile and the location map are considerably less cluttered. You are encouraged to experiment with revisiting the Options tab and changing other items within the 2D layout menu. After several iterations, you will invariably notice a number of new tabs that may cause the program to become sluggish. These tabs may be closed and deleted by clicking on the large X's within each tab title, or you can close them all by selecting the Clear button in the upper right corner of the program menu.
This exercise shows how to export cross-sections to a DXF file. Select the File Export DXF option from the RockPlot 2D tab. The program allows you to export your DXF file using the original X and Y coordinates of the profile. It also allows you to rescale with a specific vertical exaggeration and with completely new origin coordinates. For this exercise, we'll preserve the original coordinates and set the vertical exaggeration to 1, but remember that you can apply the vertical stretching or compression in your own work. This is useful because AutoCAD does not easily allow for rescaling of X and Y independently. Now, let's take a look at the layering options. The combined option will save everything within a single layer. The separate option will break the image down into separate layers. The separate option is useful if your CAD department wants more granular control over the diagram. RockWorks gives you the option to turn on and off different types of objects. Each of these layers will have a user-specified root name prefix. Each layer can also be given a unique name. Once you have finished exploring these options, click on the Output File tab. Select the Manual option and enter sampleexport.dxf for the name of the DXF file that will be created by this program. Uncheck the Display option unless you have AutoCAD or a similar program that can read DXF files installed on your machine. Before you click the Continue button, please be aware that a diagram with lots of patterns will create a very large DXF file because DXF is a verbose text format.
This step will introduce you to the RockPlot 3D viewer. We'll also be creating a few diagrams that can be used in future exercises. Start by choosing the Borehole Operations Strip Logs 3D Strip Logs option from the main RockWorks program window. Click on the 3D Log Design tab at the top of the Multiple 3D Strip Logs menu. In the 3D Log Design tab, you can establish which data items will be displayed in the 3D logs, their relative placement in the log, and their appearance settings. To activate an item, insert a check in the checkbox for that item. It will be displayed in the upper layout preview pane as color and letter-coded circles. To reposition the item, click on it and drag it to any location in the layout preview. The offset from the log center or axis will be updated in the item's options settings. To view and/or adjust an item's settings, click on its name in the 3D Strip Log Designer column and modify the settings as necessary in the Options pane to the right. Enable the Title, Axis, and Lithology options and disable everything else. Click on the lithology item and notice that the lithology options displayed in the panel to the bottom right changes to show those specific to the lithology column. Click on the lithology column radius field and change the radius to 1.0. Click on the Main Options tab at the top left of this window to access the General Diagram settings. Enable the Perimeter Cage and Legend options and disable everything else. Click on the Legend tab and enable the Lithology option and disable the others. Click the Continue button. Expand the window so that it takes up most of your screen. Note that you can move the divider between the object list, which starts with the reference heading, and the image by dragging your mouse. Reposition the divider so that the majority of the window is used to view the 3D scene. Adjust the zoom settings by typing in or selecting a new zoom factor in the top center of the window. Give the scene a vertical exaggeration of 2 by changing the vertical exaggeration field. Experiment with the other buttons at the top of the window. Practice rotating the 3D scene by dragging your mouse. Return to the default view by double-clicking on the southwest button within the menu ribbon. Choose File Save and save your RockPlot 3D view as lithologylogs.rw3d. Make sure that you save this in the Documents RockWorks Data Samples folder. In this last step, we'll make one more 3D scene, this time showing downhole geochemistry concentrations. This is very useful when looking at 3D contaminant concentrations or any other parameter that will eventually be used to create a solid model. Click on the Main Options tab and disable the Legends option. Click on the 3D Design tab and turn off the lithology item and turn on iData number 1. The iData number 1 options are displayed in the pane to the lower right. Work top to bottom through the list. Notice that as you click a name, the parameters related to that tab will populate to the right. On the Track tab, make sure that the benzene soil track is selected. Click the Column Attributes tab and change the column radius to 4%. Click on the Scaling tab and choose Automatic. Click on Appearance and set the colors to range from purple to red and set the shape to cylinders. Click Continue. A new RockPlot 3D window displays color-coded oblate shapes representing benzene soil concentration measurements. Choose File Save. Save the 3D scene as benzenelogs.rw3d. Make sure that it is saved in your project folder. Close the Multiple 3D Strip Logs window.
Next, we'll explore some additional tools for plotting downhole point and interval-based data. Select Borehole DH01 in the Borehole Manager tab. Choose the Strip Logs 2D Strip Log menu option. Make sure that the title and pData number 1 are enabled within the 2D Log Design tab. Click on the pData number 1 item to display the pData curve number 1 options pane at the bottom of the window. Click the Fill Options tab. Note, if you have problems seeing all of the settings, drag upward the divider between the Preview and Options panes. If it's visible, you can also use the scroll bar to the right to scroll within the pane. Add a check mark to the fill region within Curve option and select Gradational. Change the colors and line style if you want. Click Continue to display a strip log with colors that vary with the gamma values. Let's make 2 more adjustments. Return to the Options 2D Log Design submenu and select the pData number 1 fill options. Change the gradient to vertical. Change the fill style to above threshold and set the threshold to 25, and then click on the Continue button. You are encouraged to experiment with the other fill and scaling options available for pData, and then take a look at the similar options for iData.